In section 10.5, we talk about something called permutations and how they relate to probability. Let's start with the first example. You are at a sandwich shop that offers the following for their lunch special. Choose one type of bread and one type of meat for $1.99. Question, how many different types of sandwiches can be made? Well, there are many ways to approach this problem right here. You could draw a diagram, you could make a list, write it out, calculate. So for this one, I'm just going to, how about draw lines? So for the white bread, you can have turkey, roast beef, or ham. So there's 3 options there. And for the wheat, you could also have turkey, roast beef, or ham. So you can see from my picture right here that there's 6 different types of sandwiches can be made if you have 2 choices for the bread and 3 choices for the meat. Let's write that down. So 6 different types of sandwiches. The counting principle. If there are A ways to make the first choice, and B ways to make the second choice, and C ways to make the third choice, and so on, you can multiply those together. So for our sandwiches, there were 2 choices for the bread, and there's 3 choices for the meat. There's 6 ways to make that sandwich. So the counting principle, they're independent here. You can multiply those events and find how many different choices there will be. Let's do some examples of this. Suppose a license plate has any Suppose a license plate has any 3 letters from the alphabet followed by any 3 digits. How many different license plates are possible? I'm very visual so for these I like to draw lines. So we have 3 letters from the alphabet, and we have 3 digits. 3 single digits. So here are the different options here. And then think about how many choices we have. So if they're followed by 3 different letters from the alphabet, think of how many letters there are. There's 26 choices for the first letter. If you've noticed on license plates, you can repeat the letters. You could have a J and then another J. So there's 26 choices for the next letter, 26 choices for the third letter. Now for digits, you have the numbers, the digits, 0 through 9. That's 10 possible choices. 0 through 9 are 10 numbers. So you have 10 choices for the first digit, 10 for the second, and 10 for the third. And if we multiply those together, we'll get how many different choices we'll have. And so I've done that before, and I have 17,576,000 different ways to rearrange those letters and numbers if you have 3 letters first and 3 numbers second. Let's look at B. What is the probability that a license plate has no repeated numbers or letters? Okay, so again, I'll make my list here. So we have 3 letters, 3 numbers, but now there's no repetition, no repeated. So for the letters, we have 26 letters to choose from for the first letter, but then we've used a letter, so we have 25 for the next letter, 24 for the next. And for numbers, again, from 0 to 9, that's 10 numbers, but if we use one, we have 9 for our next option, and we have 8 for our next choice. And if you multiply those together, there's 11,232,000 different choices for if there's no repeated letters or numbers. So that's an example of the counting principle. Multiply them together. A permutation, so here's our definition for today. A permutation is an arrangement without replacement. If it is used, it cannot be used again. So it was like our previous example here. This is a permutation because we're not repeating. If we use it once, we cannot use it again. Order matters, and what that means is if order matters, ABC is not the same thing as CBA. So these would be 2 different arrangements. They don't count as the same thing. So here's an example of a permutation when order matters. 7 flute players are performing in an ensemble. The names of all 7 players are listed in the program in random order. What is the probability that their names are in alphabetical order? Okay, so this one right here, we have names of all 7 players. Okay, so I'm going to list my 7. And there are 7 people to choose from for the first, 6 people to choose from for the second name because you've used 1. If you use 2 names, there's 5 people left to choose from, and then 4, and then 3, and then 2, and then 1. And so we're not talking about probability here, but it says just how many different choices are there. If we multiply those together, we get 5,040. Different ways to do this. Instead of typing in 7 times 6 times 5 times 4 times 3 times 2 times 1, you can type in 7 factorial, and you will get the same answer. Oops. Okay, so if we calculate that, I'll show you on the Inspire. Let's open a new document here. All right, so if I open a calculator page, I'll show you where the buttons are we're going to use. So add a calculator page, and let's say I want to do 7 factorial. I will type in a 7, go to menu. Most things are under the menu. Here's probability, so we're going to use this menu quite often. And here's the factorial. So 7 factorial should be 5,040, and it is. Another way we can do this is using the permutation. It's a permutation. And in our permutation, we have this thing called NPR. N is the total number of things, and R is how many you're choosing out of. So this is 7P7. In our calculator here, we will use the permutation button. So we have menu, probability, permutation. So choose that, and again, 7, you put the total number first, and then we'll put a comma, which is down here by the pi button, and then how many you're choosing out of. So 7, and we want to use all 7 people, see how many ways we can rearrange the names. And again, it's 5,040. So there's how we can figure out total number. It says after the performance, the players are backstage. There's a bench with only room for 4 to sit. How many different seating arrangements are possible? So for this one, again, 3 different ways you could do it. We have 4 spots now, and you have 7 times 6 times 5 times 4 people to choose from. We can get that and multiply it out. And if you do that, it's 840. We can't use the factorial button for this one because we're not going all the way down to 1. But we can use this permutation thing here, the NPR. And so if I type that in my calculator, it'll give us parentheses, and N is the number, total number, 7. But now, instead of choosing all 7 people, we are only choosing 4 people to sit in those 4 spots. So 7, 4. So in our calculator, here's what it looks like. Whoops. So we do our, again, menu, probability, permutations, and it will be 7, 4. And we'll get 840 ways to arrange 4 people, or 7 people in 4 different spaces. Okay. When I actually didn't answer that last one, it says, sorry, I'm going to go back up to A. It says, what is the probability that the names are in alphabetical order? Well, there's only one arrangement out of the 5,040 that they are in alphabetical order. And so let's figure that out. 1 divided by 5,000, was it 5,040? Yep. 540, hit Control Enter. So our probability is 0.01, so about 0.02%. So probability is about 0.02% that they are in alphabetical order. Okay. Let's go to C. What is the probability that the group of 4 is sitting in alphabetical order? And again, there's only one way to do that. A group of 4. Okay, so let me go here. Okay, so again, a probability that a group of 4 is sitting in alphabetical order. So, that the group of 4. So we have 1 over what we got for our answer, 840. And that will give us a probability. You can figure that out. I guess there's another way to interpret this problem too, that as I was looking at it. So let's say we had 4 people, and we're choosing the 4 different ways they can sit. So in our calculator, NPR 4, 4. So if you're just looking at 4 different people, there's 24 ways to arrange 4 people, and then the probability that you arrange those 4 people alphabetically would be 1 out of 24. So I would accept, I guess, either. The question is kind of ambiguous. So the probability that that group of 4, so 24 ways to arrange that group of 4 and 1 out of 24, or if you're looking at a 7 people and arranging that in a group of 4, and then it's in alphabetical order, that would be 1 out of 840. All right, let's look at an example here. There are 30 people in a class. If each must give a presentation, how many different ways can the students present? So again, you could do 30 factorial, because it's 30 times 29 times 28 all the way down to 1. You could use your NPR button, and this would be out of 30 people, we want all 30 to present, so 30 comma 30. And then if you do that, we'll get our answer here. So again, menu, NPR. And this NPR button's in all different graphing calculators. Also scientific calculators have this too, so you just have to look for that if you don't have a graphing calculator. So this one was 30. Out of 30, we're choosing 30. Okay, so you can see it's a huge number. I'm not going to write that all down, but that's all the different ways that we could have 30 people present. If there is only time for 10 people to present, how many different possibilities, I made a topic here, how many different possibilities are there? So again, it's a permutation, NPR, and out of the 30, we are choosing 10. And oops, this is not the right thing. So we will have, again, NPR, and out of 30, we want 10 people to present. So you can see the number is still really big, but a lot smaller than having all 30 present. So your assignment will be to practice permutations when order matters.